So the next thing that we want to do here is we want to do the midpoint rule. So the midpoint rule, basically this is just another way to approximate Riemann sums, or approximate integrals. So if you remember, the Riemann sums that we worked with was we had R, L, right? We had the Riemann sum using the left-handed, we had the Riemann sum using your right-handed. Now we're just adding another one. So instead of using the left-handed endpoints or the right-handed endpoints, now we're just saying you can pick one in the middle. And that's the midpoint rule. Usually it's better to choose the one in the middle, right? It's kind of like taking the best of both worlds. You're not using one extreme or the other, you're using the one in the middle, but they're all approximations. So we will denote the midpoint as x sub I bar. So that's how we know we're using the midpoint. So any Riemann sum is an approximation of an integral, but if we use the midpoint, we get the following approximation. So what this does is you can actually have a nice formula. The integral from a to b of f of x is approximately the midpoint Riemann sum, which is delta x plus times f of the first midpoint plus k plus f of the last midpoint, where delta x is b minus a and x sub I is 1/2 of the previous endpoint plus the next endpoint. So let's go ahead and do an example of this. So let's do n equals 5, so we're going to do 5 subintervals from 1 to 2 of 1/2. As far as what this looks like, let's see what this looks like. So n equals 5, we're approximating 1/2, so 1/2 is just a flat line. We're approximating this from 1 to 2. So there is the area that we're looking for. Because we are doing 5 subintervals, I'm going to break that interval from 1 to 2 up into 5 pieces. The first subinterval would be 1 to 1.2, next one 1.2 to 1.4, then 1.4 to 1.6, 1.6 to 1.8, and the last one 1.8 to 2. So we need to figure out what are the 5 midpoints of each of those subintervals. So for my first subinterval, the midpoint is 1.1. For my second subinterval, 1.3, then 1.5, 1.7, and 1.9. So what that gives me is I am going to use, and this should not be a 2, this should be an x. I don't know why that's showing up there. So it's not this particular picture. There we go, 1 over x. We're going to use the 1.1, 1.3, 1.5, 1.7, and 1.9 to plug into my function. Then we're going to multiply by delta x. So that's where this last line's coming from. So it's the summation, just like we did before, the right Riemann sum, the left Riemann sum, only now we're using the midpoint. So when I plug each of those in, so this was f of 1.1, this was f of 1.3, f of 1.5, f of 1.7, and f of 1.9. When I do that, and multiply by my delta x, which was 1/5, I get 0.691. Now what were we doing? Right, what was even that approximation about? We had our 5 subintervals. Right, so I had, here's my 1.2, here's my 1.4, my 1.6, and my 1.8. And then instead of doing either the right hand or the left hand to get the height of that rectangle, I'm using the middle. So that's all the middle is. The midpoint rule is just, we're using the middle of those subintervals in order to figure out the height of the rectangle to get an approximation for the integral.